Skill 12, Applications of Algebra. In these questions, what we're doing is we're applying our algebra skills to questions that are like our measurement questions, where we're finding area or perimeter. So, looking at question 1, there are 4 parts to the question. Here's our shape here. We've got a square, and all the lengths on the square are 3x. So if you need to label it to make it really clear, you can put 3x on every edge. Part I is determine the perimeter. If we wanted to do the perimeter, we add up the whole outside. Perimeter is like traveling all around the outside of the shape along all 4 edges. So we would do 3x plus 3x plus 3x plus 3x. And that would equal 12x. Okay, remembering when we do addition, we just add the numbers out the front and we leave the letters the same for addition. We never change the letter when we're adding. Part 2 says determine the perimeter when x equals 5. So we're substituting in x equals 5. Now our perimeter is this value here, 12x. So what we need to do is have 12, and then whenever there's the letter x, we need to put the number 5 because that's what x equals now. So we've got 12 open bracket 5, which is the same as 12 times 5, which equals 60. So our perimeter is 60. Now this question doesn't have meters or centimeters in it, so we can leave it like that, but if it did, we need to write the units in. Part 3 asks to find an expression for the area. Area of a square is length squared. Our length of this square is 3x. So we need to square 3x. If we square 3x, we need to do 3 times itself. So 3 times 3, which is 3 times 3 equals 9. And then we need to do x multiplied by itself. X times x equals x squared. So if we put those together, we will have 9x squared. So our area of the square is 9x squared. If we do part 4 now, determine the area when x equals 5. So we need to put x equals 5 into our area expression. So we have 9, open bracket 5, and then the squared symbol. So we're doing 9 times 5 squared. 5 times 5 is 25. So we need to do 9 times 25, which equals 225. Now again, we don't have meters or centimeters or millimeters given to us in this question, but if we did, we would need to put something like 225 meters squared to show that it's an area, and we measure area in squared units. This is another question which is very similar to the square example, but we've got a rectangle now. So if we label the rectangle fully, we'll have 3x plus 1 on the bottom as well, and 2x on the side. If we're finding part 1, the perimeter, it'll be 3x plus 1 plus 2x plus 3x plus 1 plus 2x. Now we need to group the like terms, so we've got 3x, 2x, 3x and 2x, which all up gives us 10x. Then we look at the numbers, plus 1 and plus 1 gives plus 2 on the end. So our final expression, perimeter equals 10x plus 2. If we then do the perimeter when x equals 5, so part 2, when x equals 5, we write our expression 10 open bracket 5 plus 2, which is the same as 10 times 5 plus 2, which would give an answer of 52. We don't have any units again in this question. Part 3 we're finding the area. Area of a rectangle will be length times width. So we'll have 3x plus 1 times 2x. The way I'll probably write this is 2x out the front and then open bracket 3x plus 1. And we can expand this the same way we would with the distributive law. We multiply the term out the front by the two terms in the brackets. So 2x times 3x gives 6x squared, and 2x times 1 gives 2x. So this is our area expression, 6x squared plus 2x. Part 4, same as with the square, the area when x equals 5. So we use our area expression, 6 open bracket 5 squared plus 2 open bracket 5. This is the same as 6 times 5 squared plus 2 times 5. 5 squared is 25. 6 times 25 will give 150 plus 2 times 5, which is 10. So that'll equal 160 as our area. Again, we'll just say meters squared if we were using meters. A final example is a question where it's purely worded and there's no diagram for you. So question 5 says a square has dimensions of 5x meters. So let's draw the square. We know that every edge will be the same and every edge is 5x according to the question. So we'll have 5x on every side. You want to label them all. Part A, write an expression for the perimeter. So all the way around the outside. So 5x plus 5x plus 5x plus 5x will equal 20x. Alright, we only add the numbers out the front and we don't change the letter when we're using addition and subtraction. For part B, write an expression for the area. So we need to do 5x squared. Alright, another way of thinking about this if you want to is you can also do 5x times 5x. If you want to look at it that way, which might look easier, it's 5 times 5 is 25 and x times x is x squared. So the area is 25x squared. Part C. Part 1. If the length is decreased by 2 meters, write an expression for its new length. So the length is decreased by 2 meters. If we're decreasing, we are subtracting 2 meters. So the length at the moment is 5x and we need to subtract 2. So that's our new length. If the width is decreased by 3 meters, write an expression for the new width. So same thing, we're doing the width now. We're decreasing by 3. So the width will be 5x, take 3. Write an expression for the new area. So the new area now, using our two new calculations. This one here and this one here. So the area will be, we're multiplying length by width. So 5x take 2 multiplied by 5x take 3. So we're going to use FOIL for this because it's two sets of brackets. So 5x times 5x gives 25. 5 times 5 is 25. And x times x is x squared. 5x times negative 3. 5 times negative 3 is negative 15. And we've got x left over. Negative 2 times 5x is negative 10x. And negative 2 times negative 3 gives positive 6, because a negative times a negative is a positive. Now we need to collect any like terms. So we've got an x and another x in the middle. They're the only like terms. So our final answer 25x squared. Negative 15 take 10 is negative 25x, and then plus 6 on the end. This is our new expression for the area. Calculate the area, part 4, when x equals 6. So we need to substitute in 6, 25 open bracket 6 squared, take 25 lots of 6 plus 6. So if we put all of that straight in the calculator, we'll get an answer of 756 as the new area, for example, in meters squared. But we would always use the calculator for a difficult calculation like that. Whenever you're not sure, you should always use the calculator.